Hello everyone, let us continue our discussion on corrosion protection methods, and today is the second lecture. The course is and today is lecture 2, and the today's topic will be environmental conditions. Now, when we talk about environment, we have to also see that what are the species that are active for the corrosion process, and this environment can be of varied nature depending on the position of that metals and alloys component. When I talk about position, it can have its actual physical position at one place, like whether it is in the air or atmosphere, or whether it is below the earth surface. And when we talk about below the earth surface, we have to see whether it is exposed to soil or it is exposed to aqueous medium. Now, when we talk about aqueous medium, it could be river water, it could be sewage water, it could be salt water or sea water, all those conditions would come up. Now, if we see the another where another condition is basically geographical location. Now, depending on whether the metals and alloys are placed at a high altitude region or a low altitude region, or the plain I would say, or whether it is in the plain. If we consider the plain, then it can be exposed to coastal areas, or it can be exposed to away from coastal areas. The condition would also vary. So, that means one is its position below the earth surface or above the earth surface, and the second one is whether which geographical location it is there. So, depending on that, let us list down all those conditions. Why those condition listing is important? Because the interaction of metals and alloys in those conditions will be different. Same metal can behave differently in different locations. So, we have to have idea about those conditions. So, let us check those conditions, and in fact, it will help us in designing or thinking about the protection routes or methods. Sometimes you might find that no serious protection methods are required, rather than by simply changing the shape or the surface nature, we can get very good quality of protection. So, let us list down. So, when we list down, we have to see that if this is my earth surface, so something could be in soil, something could be in electrolyte. When we talk about not electrolyte, rather in soil is also there will be electrolyte. So, it say that aqueous medium, and then the other part is atmosphere or open atmosphere. We call it as air atmosphere, fine. So, let us consider first the air. Now, that is what we come to that part called atmospheric corrosion. So, in the air, what are the conditions? The conditions could be, one is presence of oxygen. So, it could be low, it could be high. Now, when we talk about high, let us say normal atmospheric pressure, we can say that it is on the plane, and here it is high altitude. Okay. So, that means that two situation, oxygen can be low, oxygen can be high. Then we have a presence of moisture, it actually leads to change in humidity. So, one air could be highly humid, one air could be having low humidity, like let us say Ladakh, which is high altitude area where humidity is very low, and whereas in Kanpur or Kolkata or Chennai there will be a lot of humidity. So, it can be low, it can be high, fine. So, then there could be presence of industrial gases which can act as a serious corrosive, like presence of SO2, CO2, all those gases can be present. It could be high or it could be low depending on whether that particular materials are exposed to near industrial belt or away from industrial belt. Like in Kanpur it is a big city and there will be lot of vehicles and other industries where the gases coming out from that contains a lot of SO2 or CO2 gases. So, that atmosphere would be highly acidic if rain happens. So, that is what the acid rain problem could be very high wherever we have SO2 or CO2 level in the atmosphere. And acid rain would lead to a serious damage to concrete structures. Okay. So, that is the problem. So, it can be low or it can be high. There could be possibility of temperature, it could be high or low. So, here or it could be high or low. There could be NaCl vapor, it could be low, it could be high. For example, near coastal area the vapor, the air contains a lot of NaCl molecules. So, the possibility of corrosion attack would be much higher because the chloride related incident near coastal areas rather than the area which is farther away from the coastal areas. Okay. And of course, pressure. So, this pressure, okay, so this pressure, I think when I talk about pressure, it is a low pressure or high pressure, and that low pressure or high pressure also relates to this industrial gases as well as oxygen or even moisture, fine. So, those effects will be there. So, these are the these are some of the effects what we can think of. Now, depending on that situation like this, the pH can be considered. So, pH could be high or pH could be low if the rainwater contains those carbon dioxide mixing with SO2 mixing with rainwater and forming acids, and that acid means the pH would be low, and some places where the rainwater happens without having those kind of gases, then the pH would be near neutral. The corrosion pattern would also change, right. So, these are the condition which what we can think of in air, fine. Now, then we can think of soil. The soil, that means it is below earth surface. So, if we say that this is earth surface, so the soil again it could have low oxygen and high oxygen, and that time we can mention partial pressure of oxygen, it could be low, it could be high. Moisture, it could be low, it could be high. Then of course, presence of chloride ion, it could be high, it could be low. And it is not only chloride ion, I would say that there could be presence of several halides like bromide, iodide or fluoride, those halides can also be present, fine. Now, then there could be possibility of presence of acids like H2SO4, HNO3, HCl, all those acids can also be present. Now, wherever these acids are used, like let us say pickling plant where HCl acid is used, and the pickling plant what it does, it removes the mill scale or oxide scale over the rolled steel product. So, that means it is a huge tank and there will always be spillage of HCl, and that HCl can go to the soil and then it can contaminate the soil, and if there are pipelines in the soil, definitely that acid effect will come in. Now, one is acid, then for example, another acidic problem is now the small scale industries like let us say gold coloring. I am just giving you one example that gold coloring process uses concentrated fuming sulfuric acid, and here coloring does not mean that physically some color is coated on top of the gold ornament. What happens if we make 22 karat gold? That gold is dipped in fuming sulfuric acid, so that little bit of dissolution happens. Dissolution of what? Dissolution of other elements which are added to it. If it is 22 karat gold, then there could be presence of silver and copper. So, this copper and silver, they go little bit into the solution, and then that is what the gold enrichment happens on the surface. So, the gold initially 22 karat gold is 91.66 weight percent gold, but once we get to this pickling process or the coloring process, the gold content on the surface might increase up to 97% of gold. So, that means the surface would become very shiny, very yellowish, bright yellow, I would say. So, those plants, when you have those acids if we do not store it properly, that can go into the soil. Again, that soil will be contaminated. Like in Kanpur, there are a lot of tanneries, and in the tannery we use a lot of strong acids, and definitely those acids are actually going into the soil, and the acid contamination in Kanpur soil is a serious problem. And there are metal objects like pipelines, those pipelines will be facing trouble, high degree of corrosion due to the acidic soil in those localities. So, this acid is a problem, acid content, it could be low, it could be high depending on the localities or location where this material is used. Now, in soil there is another condition which should be considered is bacteria. So, bacteria could be aerobic, anaerobic, all those bacteria presence would have a different degree of corrosion on the metals and alloys components in those soils. Now, apart from that bacteria, there could be pH effect. Of course, when we talk about pH effect, it could be neutral, it could be basic, it could be acidic. Okay. So, that means depending on the constituents present in that soil, it can have several pH level, and at different pH level one material can behave differently. For example, high pH, very high pH is good for iron protection in concrete, and that pH level should be around 12.5 to 13. But if we go beyond that, it is not good. It will actually dissolve the rebar. Even if the pH goes below 10, again there is a problem. So, that means sometimes we have to operate in a particular window of pH for getting a very good protection or rather long term service of that material. Like in concrete, we have to maintain that pH around 12.5 to 13, and this acid rain actually leads to problem there. When acid rain happens, if the rainwater percolates through the concrete cover to the metal surface, that means the rebar concrete surface, the rebar would have a high degree of corrosion, because we lose passivity there. Intentionally we introduce passivity in the concrete rebar, but if that passivity is lost, definitely the rebar would have a higher degree of corrosion. And in concrete, if rebar corrosion happens, it is a serious matter, because the concrete is not deformable. Okay. So, and those whenever that rust forms, because if the pH goes down, it will dissolve and the rust will happen, and the rust will have higher specific volume, and if higher specific volume happens inside the concrete, it will lead to hoop stress, and that hoop stress can have a cracking effect on the concrete. And once a concrete structure is cracked, that structure has lost its purpose. Okay. So, that is what those conditions are very important. Okay. We have to have a conditional awareness to get to the fact that what kind of protection we should use or what kind of material we should use. Those kind of things will come up if we know those conditions. So, that is what it is very important to mention all those environmental conditions. Now, if we talk about soil again, there could be high temperature as well as low temperature, low high. Definitely, because if we have high altitude, definite temperature, average temperature would be low. If we go to the low normal, let us say in Kanpur, the summertime temperature goes up to 45 degrees Celsius, whereas winter it goes to 2 degree or 4 degrees Celsius. So, that means it is extreme variation in temperature. So, that variation in temperature material should withstand that. At the same time, if we go to a high altitude region near Himalayas belt, we have average temperature around 15 degree, 12 to 15 degree during summer, and during winter of course it will go down below sub-zero. But temperature, higher temperature has a problem. If the corrosion process is going on, and it is a reaction, it is a chemical reaction, though it has an electrochemical nature, but chemical reaction, the thumb rule is with every temperature increase we have an increase in rate of that reaction. So, that means the corrosion process would also fasten. Okay. So, it will also become faster, fine. So, high and low temperature, and of course, we have talked about pressure. So, these are the kind of conditions we can experience. Now, let us go to electrolyte or aqueous electrolyte. Aqueous electrolyte, again here we talk about dissolved oxygen, and the dissolved oxygen can also be converted into partial pressure. So, it can have high dissolved oxygen or low dissolved oxygen, fine. Then there could be, of course, water is ample there, we do not have to bother about that, but since it is a water medium, we have to consider the pH. It can be high, low, medium, that means it could be neutral, basic and acidic. Then we have to talk about different presence of ions, chlorine ion or halide ions, that could be high, that could be low depending on the locality or the location. Coastal area, chlorine ion concentration would be very high, away from coastal area chlorine ion concentration would be very low, and the corrosion process would also be different. Okay. Now, then we have several other ions present like H2SO4, HNO3, other salts. Now, whenever these salts are present, what it does? It actually improves the conductivity. Now, interestingly, one way to protect metals and alloys, if we can increase the resistance path for the charge transfer or electron transfer. Okay. So, now if we have a very high resistant electrolyte, definitely the corrosion would be less. Like let us say you use deionized water as well as potable water, same iron if you expose that iron into two different environments, other conditions if you keep fixed, you will see that in deionized water the iron corrosion would be very, very low, because there the resistance is so high, the electrolyte resistance is so high, it will not allow the charge transfer. So, that means the circuit what we have talked about in the previous lecture, that electrochemical circuit should be complete, that circuit will have difficulty in completion. That means the resistance path would be so high, the resistance polarization would happen, and then it will lead to a very low degree of dissolution. Fine. So, that means whenever this salt or those ions are present, so that time you can have effect of conductivity. So, conductivity could be low, could be high. Now, here also I can think of conductivity. So, we should mention there another condition is we can have conductivity issue also. Highly conducting soil, lowly conducting soil, those conditions can be possible, and that actually decides what type of cathodic protections you need, whether you need impressed current cathodic protection or sacrificial anode. And even if you think of sacrificial anode, whether you need zinc, whether you need magnesium, whether you need aluminum, that will be decided by the conductivity of that soil. Okay. At the same time, other species present in that soil. So, we have to understand the constituents of soil. Now, once we know this, then of course, temperature is a factor. If temperature is high, if temperature is low, the pattern of corrosion pattern would change. Mainly high temperature always led to problem in having passivity. So, if some material is protected because of the passive layer formation, if the temperature is very high, the passive layer formation, passive layer can become destabilized. So, if you can destabilize the passive layer, the corrosion would be much higher. Okay. So, temperature is a factor. Of course, here pressure means of course this partial pressure of oxygen. Bacteria can also present. Different ions, metal ions like Fe+3 or copper plus, those are possible, and in fact those actually leads to lot of trouble. Let us say a iron pipeline. If we have an iron pipeline and let us say potable water flows through that pipeline, and if there is by chance a possibility of copper ion contamination, what would lead to, you have this pipe, you have copper ion, and now this is iron pipe and this is potable water. Now, there could be possibility of copper deposit, because this 2 electron it can deposit. Once it deposit, and that deposition point, since copper is present above iron in the galvanic series, so the copper part would act as cathode. So, the cathodic reaction happen there, and just by the side. So, if cathodic reaction happen here, next level of reaction pattern cathodic. So, more cathodic reaction would happen here. So, the near that place would have a localized anodic dissolution because of the higher rate of cathodic reactions there. So, in fact, there is a possibility of leakage. Fine. So, now if we have that idea that copper ion is present, we should make sure that the copper ion should be tackled before it flows into the water iron pipeline. So, again we see that the protection is not about having something on the material composition or microstructure or having some coating or some other means. Rather, if we stop those corrosives, in fact this copper ion is acting like a corrosive in a different way, because when copper deposits, that particular part becomes preferential cathode, and the near that place there is a possibility of leakage, because near that place preferential anodic dissolution would happen and the leakage would happen. So, that means we see that protection does not mean that having some methods, rather than method would be absolutely different, absolutely unique. Just by tapping copper ion we can stop this kind of problem in the pipeline. So, we have to have, again I am saying that what I would like to mention, that we have to have idea about the conditions. That is very important while choosing corrosion protection routes. Now, then if we see this aqueous medium, are we missing anything? I think we have considered almost all the things. No, I think couple of things. Let us say flow velocity. This is also very important aspect. The flow velocity, what it means, that whenever we have some aqueous medium, there could be stagnancy, there could be flow, and the flow could be very high, very low. Even when flow happens, that flow could be clean flow, or there could be a lot of dirt present along with the flow, and every situation the corrosion pattern would change. For example, if we have lot of dirt, see this dirt when it flows at a high rate, it could actually hit the surface. For example, if we take a pipeline, if we have a clean flow, no dirt, the effect of leakage around this place would be less. But once we have lot of dirt, so that dirt will hit that particular part in this part, and there could be dent formation or scratch formation. So, erosion corrosion tendency erosion corrosion tendency will go up. So, now dirt acts in this way. There could be another way dirt will be very bad. Let us say while flow happens, if the flow is not sufficient to take those dirts away with it, some of the dirts will settle down. Let us say some dirt settle down here. So, this particular part there is a small dirt. So, if we check, if we zoom it, this is my dirt. Now, interestingly, when the dirt is present and let us say if it is a heavy dirt, so it falls down and it actually deposits at the bottom, it actually reduces the orifice. So, that means the water flow is hindered or the aqueous medium flow is hindered. So, that would lead to another problem is turbulence. The turbulence is another issue, we will talk about it later, but let us say the dirt is settled at the bottom. So, you are actually creating a crevice. So, now once crevice is formed near that dirt region, you will see that the corrosion attack happens. Corrosion attack happens. So, now if we see, if we know that whether that particular medium has dirt, if we can design something which actually filter out that dirt before it enters in the pipeline system, we can have good amount of protection, long period of operation. Now, coming to the flow velocity, if the flow velocity is very high, the possibility of having pitting corrosion can be very low. If it becomes stagnant, the possibility of pitting corrosion would go up. In fact, sometimes pitting corrosion can be so severe that it can perforate the surface. Okay. So, flow velocity is also another important aspect in the aqueous medium. So, we should talk about, we should know about it. So, now if we see all those conditions, there will be one more factor that are important, that will be important, like radiation. The radiation can be possible in the soil, in the aqueous medium, as well as in the atmosphere, open atmosphere. So, those radiation, for example, nuclear industry, there would be possibility of swelling, okay, the swelling of steel, and that swelling happens because of the interaction of radiation with the metal. There could be vacancy formation, and that vacancy will combine each other and then form a void, and that void would lead to swelling of the material. So, we have to also think of there, I think most of the cases the protection will have a bit concentrated one, and those protections are costly one because we have to change the material. Generally ferritic or magnetic steels are good to resist swelling. Okay. So, we have to use those costly steels for the operation of nuclear plants. Okay. So, again everywhere we see that radiation is coming into picture. So, now if we try to make it a kind of graphical representation, so we can have, here we have metals and alloys. Let us say this is my earth surface and this is air or atmosphere. This is electrolyte, aqueous electrolyte. This is soil, fine, and if we see overall radiation, it is effective everywhere, and you just note down those one by one, those factors what we have talked about. You can note down all those things, and this will be a graphical representation of the conditions what the metals and alloys are experiencing. And out of that we have to see the position, that means where it is in below the soil, below the earth surface or above the earth surface, and then another one is geographical location. These two are also equally important. Now, we have talked about some of the conditions that metals and alloys are exposed to, but when we talk about metals and alloys can have several variations within itself, like composition. Composition could be different, microstructure could be different. The same composition, we can have several microstructures like steel. Let us say plain carbon 0.2% carbon steel, we can make it ferritic ferriti-paralytic, we can have a higher degree of cooling rate so that the microstructure becomes finer, we can have martensitic, we can have tempered martensite, we can have benitic structure. So, all those microstructures are possible, and of course, those steels are exposed to the same condition, the attack pattern would also change. Now, if we have different compositions, the permutation and combination of all those microstructure and compositions, it can lead to n number of variations, and every variation we would have different effects, but at least we should have some idea about those variations and how the corrosion is affected because of those variations, we should know. I think we should discuss that particular part, the materials variation and the effect on the corrosion, in our next lecture. Till then, thank you.